Bueno, pues voy a hacer un poquito una pequeña introducción sobre la nueva Internet de las cosas, de las identidades y de las personas. Todos estamos familiarizados con lo que ha sido la evolución de Internet, que sabemos que empezó dentro de las áreas de defensa. Ya llevamos más de 55 años. Yo, como anécdota chascarrillo, diré que empecé en la escuela trabajando en el laboratorio de mecánica, pues haciendo toda la programación en control numérico de los tornos que teníamos en aquella época por allí, y también en el laboratorio de metalurgia con un pequeño ingenio de la época de la Tana en el que éramos capaces de programar cosas y que salieran adelante. Ha sido un largo camino ya de más de 55 años y quizás algunos recordaréis, como yo, que incluso hace bastante tiempo, en el 1995, existía un navegador que se llamaba Altavista. Hoy nadie ha oído hablar de ese navegador. La velocidad de transformación en Internet está siendo absolutamente equiparable a la velocidad de la luz. En paralelo, y ya con nosotros desde hace más de 30 años, tenemos los primeros avatares de la tecnología blockchain, allá por 1991. Quiero aquí separar esta charla completamente. No hablo de Bitcoin, no hablo de criptomonedas, hablo de blockchain como una herramienta que lo que nos va a permitir va a ser dar un salto. ¿A qué estamos acostumbrados en estos más de 55 años de Internet? Pues a trabajar con transferencias exclusivamente de información, textos, imágenes, programas, vídeos. Y el gran salto y el gran reto que vamos a afrontar gracias a blockchain es que vamos a poder hacer transferencia de activos. Vamos a poder transferir dinero, pero dinero ya no solo bitcoins, sino el dinero que tenemos en nuestras cuentas corrientes, contratos, propiedades, casas, derechos. Se va a producir una desintermediación absoluta, es decir, no vamos a tener el caso de un Airbnb en el cual estamos con un intermediario alquilando nuestro apartamento. Lo que vamos a hacer es alquilar directamente con el posible cliente final. Esto requiere toda una gran transformación. El mundo va avanzando. Si alguien intenta en este momento, escribe en Internet blockchain landscape, encontraréis una cantidad casi infinita de soluciones que están proliferando en distintos ámbitos, tanto del mundo de las finanzas como del mundo de la ingeniería, donde Bart nos va a explicar más en detalle a qué altura estamos ahora en este momento. Googlear un poquito, no altavistear, que ya no existe, pero googlear un poquito con blockchain landscape y encontraréis montañas de información. A mí me gusta y soy un fiel seguidor de Gartner, y aquí vemos un poco el hype cycle desde el punto de vista de las cutting edge technologies del pasado año. Y ya veis aquí como todo el tema de pasaportes sanitarios, el gemelo del ciudadano, todo el mundo, son temas que están en boga. Más concretamente, este es el hype cycle for blockchain technologies y cuál es su evolución. Como vemos, estamos en el inicio de toda la actividad. No estamos en el periodo ya de madurez, como podríamos ver en el caso, por ejemplo, de la inteligencia artificial, que parece también algo relativamente moderno, pero que en su curva de madurez, por ejemplo, está más avanzado que el empleo del blockchain en este momento en las aplicaciones en todo el mundo. Decir que esto también es un gran negocio. Estos son unas estimaciones de lo que va a mover el mundo de la tecnología en blockchain, esperándose pues que del 2020 al 25, en un poco más de 5 años, pues multiplicamos por más de 10 el volumen de inversión que se va a realizar en este tipo de plataformas. Pero esto es solo referido a la tecnología. Si hablamos del mercado que hay detrás, de qué es lo que se va a mover. Cuando estoy diciendo yo que se producirán transferencias de activos, aquí lo que estamos hablando es de un mercado que, según unos analistas, podría llegar a los 203 billones americanos de dólares. Pero según McKinsey, por ejemplo, podría suponer de un 3 a un 13% del PIB mundial, con lo cual nos iríamos a una cifra de 2,5 a 11 trillones de dólares. Ante esta tesitura y que vamos a empezar a intercambiar cosas, mi pregunta es, y es la que os lanzaba aquí en esta traspa, ¿será importante verificar la identidad de las personas? ¿Será importante conocer la identidad de las cosas que vamos a transferir dentro de ese nuevo ecosistema? Pues si no va a haber un intermediario que vele por las transacciones, sino que lo vamos a hacer en un mundo abierto, pues parece efectivamente que va a ser trascendental el asegurarnos y verificar tanto la identidad de las personas como la identidad de las cosas. Voy a poneros un ejemplo un poco para aterrizar los paradigmas que existen entre la credencial física actual y la digital. Y para ello me voy a basar en algo que todos conocemos, que es el pasaporte. Podemos decir que la credencial es el propio pasaporte, que tiene toda una serie de datos, y el identificador, por excelencia, es el número de pasaporte. Pero también tenemos una característica curiosa, que es el Machine Readable Zone, el MRZ. Este MRZ corresponde a un estándar definido por la International Civil Aviation Organization, que es la encargada de definir esto, cómo se debe escribir para que puedan leerlo las máquinas. Pues en este paralelismo, en el mundo digital, similar a esta credencial que tenemos como pasaporte, sería esta otra credencial verificable, donde el identificador, en vez de ser el número de pasaporte, sería este DID o DID, que no creáis que es, como me pasaba a mí al principio, el Digital Identity, sino el Decentralized Identity. En este caso, en el ejemplo, pues al final corresponde a una clave determinada, a la que acompañamos de otros atributos, lo mismo que teníamos en el pasaporte. En este ejemplo lo que tenemos es una clave similar a la que teníamos con el pasaporte, pero que vamos a utilizar dentro de todo lo que es el nuevo mundo digital de la Internet de las identidades. En este caso no es ICAO quien define, sino quien se proclama como ente encargado de la definición de todos estos estándares, es el W3C, que es el World Wide Web Consortium, y es quien universalmente está aceptado como aquel que dictamina bajo qué normativa y estándares vamos a generar estos identificadores. Al final, pues aquí tenéis la credencial física en soporte de papel o plástico, que es, digamos, nuestro pasaporte. Quien gobierna, hace la gobernanza es ICAO, como veíamos. Tenemos datos que son las credenciales que acompañan al pasaporte, un estándar definido y un formato que normalmente es agregado de toda esta información y está colectivamente almacenada normalmente en una base central también del gobierno. A diferencia de la credencial física, la credencial digital, como hemos visto, su soporte lo tiene en el mundo electrónico. El órgano de gobierno, como hemos dicho, es el W3C. Utilizamos credenciales verificables y utilizamos el DID dentro de un formato que va a ser completamente distribuido. Al final, pues estamos, por ejemplo, si yo comparo el mundo de Internet de la información con el mundo de los activos, yo como voy a definir las cosas en el mundo de Internet es con las URLs que estamos acostumbrados a ver cada día que entramos a navegar, y sin embargo en el mundo de blockchain lo que vamos a tener son estos DIDs, que lo que van a definir es con qué metodología estoy transcribiendo una determinada clave y cuál es la clave que uso. Aquí, por ejemplo, tenéis pues un tipo de encriptado de estas claves digitales u otro tipo de estándar para definición de esas claves. Para el caso de las identidades de las personas, en lo que se está trabajando ahora es en la gestión de credenciales verificables. Os puedo decir, bueno, un poco nuestro presidente anticipada, que yo también trabajo en esta compañía que se llama SICPA. Hemos estado trabajando hace 2 años con el gobierno de los Estados Unidos en Homeland Security, en el proyecto, uno de los proyectos más novedosos, que es todo el que se relaciona con el Valle de la Innovación en Estados Unidos, el Silicon Valley, y estamos dentro del Silicon Valley Innovation Program, SBIP, y ahí hemos preparado las credenciales verificables para el Green Card, la famosa tarjeta verde de Estados Unidos. Básicamente, por explicarlo en un modo rápido, lo que tenemos es un emisor de esos certificados, tenemos el titular, que va a ser quien va a recibir ese certificado, y tenemos a alguien que está para verificar esa credencial, ese pasaporte. Aquí en el mundo físico sería pues donde vamos a recibir nuestro DNI o nuestro pasaporte, que es el emisor, nosotros que somos los titulares y el verificador, que sería, pues, por ejemplo, alguien en aduanas que va a verificar nuestro pasaporte. Lo primero que haríamos sería solicitar al emisor, por ejemplo, mi credencial verificable para poder viajar o para poder tener mi pasaporte digital o mi identidad digital. Esto iría acompañado de la visualización de mi foto. Lo primero que se hace en lo que se llama el enrollment es la verificación de que quien está solicitando es quien dice ser. Y entonces incluso lo que se preparan son herramientas tipo liveness, donde se ve que no he puesto una foto de alguien que estoy suplantando, sino que soy yo. Y verificamos por los movimientos que se realizan al hacer la foto y al estar en contacto en la solicitud, que es una persona real quien está detrás. Digamos que el emisor tomaría, gracias a esa preidentificación de la persona, sus datos de su almacenamiento de datos, generaría las credenciales verificables de datos junto con lo que nosotros estamos desarrollando, que es un hash de la imagen. Es decir, vamos a grabar una especie de huella digital de la imagen que vamos a almacenar para posteriormente poder verificar esa credencial. Una vez que se ha realizado esto, se le envía la credencial a la persona, que la almacena en su wallet. Su wallet, que es normalmente su teléfono móvil. En el siguiente punto ya tengo en mi wallet esa credencial verificable que ha sido emitida por un organismo oficial. Yo puedo ir, por ejemplo, a hacer un trámite de pase de una aduana y lo primero que me van a pedir es quién soy yo y cómo me acredito. Entonces yo presento esa credencial verificable que tengo en mi wallet y el verificador accede a la nube de blockchain para verificar que efectivamente esa persona que soy yo, con esa foto, coincido con la información que tenemos en blockchain, haciendo también el cálculo del hash de la imagen para contrastar que efectivamente todo está en orden. Yo soy quien soy y presento mi credencial ante la autoridad competente, de forma que se verifica mi certificado. En esto consiste el proyecto y en esto consistió el proyecto que realizamos para Estados Unidos, para el Green Card, y análogamente ahora estamos con el SIFLAB, que es con la Unión Europea, en un proyecto muy innovador también, generando credenciales verificables para la identificación de las personas en este momento. Bueno, al final la salsa secreta de Secret Sauce que está alrededor de todo esto es una blockchain en la que no voy a entrar en todos los detalles técnicos, pero donde podemos garantizar toda una serie de ventajas en su utilización, la principal, la seguridad, la inmutabilidad de los datos, el sello de tiempo de toda la información que tenemos, todo encriptado y, por ejemplo, cumplimos con la DGPR todo lo que es protección de datos, ya que, por ejemplo, en temas de biometría, que hay sus más y sus menos en cuanto a tener esta información almacenada, lo único que almacenamos es una huella digital, un subproducto de puntos que tomamos, por ejemplo, de la biometría de la cara, la distancia entre los ojos, el arco de las cejas, la distancia entre la nariz y la boca, toda una serie de datos que lo que nos permiten es crear un símil de la imagen, que es el que almacenamos, del que no se puede hacer reingeniería inversa para luego extraer la imagen y hacer suplantaciones, ¿no? Entonces, bueno, pues en esto es en lo que estamos trabajando. Muy importante el plan de digitalización de las administraciones públicas, que ha salido recientemente a la luz. Habla de todo el periodo 2021-2025 y donde en la medida 4 del primer eje tiene fundamental trascendencia los nuevos modelos de identidad digital, como estamos aquí viendo. Bueno, y aquí termina mi corta historia un poco de cómo identificar y por qué identificar a las personas, lo cual consideramos absolutamente crítico para este futuro, pero no he hecho más que ser un poco telonero de la gran actuación que es la que espera a Bart, que es francamente un fuera de serie en estos temas con una experiencia dilatada y amplísima en todo lo que es blockchain, las credenciales verificables, y verdaderamente es un visionario de cómo va a ser el futuro, y mucho más que mi presentación, la suya va a estar ligada a nuestra actividad como ingenieros industriales en todo lo que son las cadenas de suministro, las cadenas de fabricación y cómo hacer una trazabilidad eficiente de todos los productos a lo largo de todo su ciclo de vida. Muchas gracias.
Muchas gracias, Fabián. If you don't mind, we're going to switch to English now. We're going to give word to Mr. Bart Suichies. As we were saying before in Spanish, Mr. Bart Suichies has an education in technology management. He's been working around project development and among other areas. And today he works in the sort of forecasting or imagineering, as I have here, the next generation of trust-enabling security systems for citizens, central banks, and governments. From what I gather from his short CV, I think he has a very strong technical background, and he can delve a bit deeper into some of the things that and interesting aspects that Fabián has outlined in his presentation. So without further ado, I give word to Mr. Bart Suichies. Thank you very much.
Thank you, Ignacio, and thanks for hosting me as a non-Spanish speaker. I followed Fabián's presentation with great interest because I know the topic, but I didn't know the Spanish, so it's I get some good practice here today. So I am sharing my screen if all is well. I want to talk a little bit about supply chain and decentralized microcertificates, which are a manifestation of credential-based identity, which was just discussed by Fabián. Let's see if I can. Yes, I can get this to work. So I wanna start by outlining a little bit of context on how we see the nature of supply chains changing over time. Then move into how microcertification as a concept can address some of the key trust issues. The underlying technology principles, so I will dive a little bit deeper into the technology of credential-based identity, and then ultimately we'll show a little demonstration of how we can apply these certificates in regulated industries. So if you look at supply chains, you can see something quite interesting happening over time. So if you look at the past, you saw a lot of vertically integrated organizations where the logic was quite simple. You would basically manage the whole thing yourself. You would own everything, and it was the matter of coordination was strictly inside your own business. But with sort of digitization and travel, we see that is moving to where we currently are is globally coordinated supply chains. So here the relationships are more one-to-many, where you have often a big brand creating a supply chain which is all over the world, and the name of the game really here is control. How do we control the supply chain? We see, interestingly enough, with COVID and some sort of systemic shocks, that this is a system which has its limits of how efficiently we can go without risking big outages in the system when we have these types of shocks. And looking a little bit into the future, and we already see this happening, is that we see value chain ecosystems arrive. And here the name of the game is much more collaboration, many-to-many relationships, even between competitors. So a good example of this is, for instance, the relationship that Samsung has with Apple, who on the one hand are competing, but on the other hand are also supplier in each other's supply chains. And it's this type of dynamic which is quite interesting, because here you need a lot of collaboration, requires a lot of insights, and as these ecosystems grow larger, they become more complex. So how do we design the system for trust to get those insights? And this brings us to something where I think the blockchain has traveled quite a bit on the Gartner hype cycle, because trust requires integrity of information. But integrity of information usually comes from one of two things. Either it comes from a trusted third party, like a bank or a broker or some sort of intermediary, or from what we call transparency-based systems. And these are usually sort of public registries. And this is where blockchains have really made a mark. But both of these options, they are forgetting something really important. And I feel that we're starting to see that now, because a lot of initiatives are not getting past the pilot stage. And that is the fact that they ignore the need for business confidentiality. So is there another way to create integrity? This problem is actually exaggerated when Industry 4.0 hits, because with 5G, you get high throughput, low latency, you get more computational power in small things at the edge. And this pushes automation and decision-making really to the edge. But then the question becomes, how do you get relevant data to the point of decision? And second part is, how do we get that data to be trusted? So this is where we really started our exploration into microcertification, to really see how do we get the data in the right place and how do we make sure that it's trusted while retaining business confidentiality. So we started our research with. Sorry? No? Okay. So we started our exploration with three hypotheses. The first one is that we are moving from what we call point-based authentication. So at one point in time, I look at one piece of information and authenticate that, to validation due to consistency over time, so longitudinal, and over a graph of independent sources. So is a car coming from a factory line, is that still the same car when it hits the showroom? That is consistency over time. So that's the first hypothesis. The second one is that consistency is something that you can prove cryptographically while retaining business confidentiality. So there is no need to have a large public registry where everything is out in the open. You can actually do this by keeping all this information confidential, but have it be cryptographically verifiable. And if those two are true, if we can prove those, we feel that we can remove one of the biggest barriers of adoption of these cross-organizational data exchange systems that are required if you go to this collaborative value chain ecosystem. Which brings us to the concept of microcertification. So we tried to find a definition of this, and this was the best we could come up with. It's basically a method that binds verifiable manufacturing and supply chain events to a given product or batch as it moves through the supply chain all the way from creation to release, all while retaining this business confidentiality. And the idea is actually pretty simple. What if a product or a batch of products holds all its relevant information with itself as it travels through the supply chain? So this is containing information around sort of more low frequency and generic certification like ISO or FSC, GFSI certification. And this is typically created by SGS or DNVGL, sort of third-party auditors, and they are generic to the producer. On the other hand, you have things which are much higher frequency and much more specific. So that's just information coming from logs books, from standard operating procedures, and they often have to do with quality and conformity. And they're sort of self-assessments. They have high frequency and they can be made specific to a batch. The interesting thing here is that with Industry 4.0, a lot of this information resides in digital systems. And when you go to regulated industries, these systems are qualified, which means that you can trust them. But even if they're not trusted, if you look at the consistency of data over time, you can start to see some very interesting things. And then the question becomes, how can we do audits through a product's digital twin? Because if a twin has all the information that it needs and it can prove things about itself, we can vastly increase the fidelity of our audits. So instead of asking if a product was produced slave-free, that is a much better question than, did this product come from a producer that is certified slave-free? I think that this fidelity is actually quite interesting because it doesn't matter if you are ISO 9001 certified, you can still make swimsuits out of cement because that certification doesn't say anything about that specific batch. And with microcertificates, you basically solve that problem. So we come to a system which actually addresses some of the key issues in supply chains. The first one being data currently stuck in silos and events that are logged inside an organization, sometimes even within plants. It's very hard to retrieve and very hard to audit. Making that information available across organizational boundaries is something that right now is super hard to do. Many companies that have SAP systems and things like that, they're perfectly fine if they succeed in liberating the data which is inside their factory floor. But to get it from inside your SAP system to outside, to working with your vendors, to working with your clients, to really collaborate around sort of do stock management, do all sorts of things, is really, really hard. And microcertificates allow you to share data that travels with the product, and the product or the batch of products or the batch of components can prove things about themselves at the point of the decision. So they enable really verifiability across the supply chain. And that gives you really fine-grained auditability. So a collection of certificates, and you can envision sort of with a car, this could be hundreds or thousands of certificates, can really reflect the output of the actual process that a product went through, rather than what it was supposed to go through and somebody who signed off on it. That reduces the cost of compliance because it's the output of the actual process and it's independently verifiable. There is very little need for additional audits because you can show consistency over time and over different sources, both internally as well as through third parties. And interestingly enough, you can do that while retaining business confidentiality. And this is somewhat counterintuitive because you can say, well, if I have an overview of microcertificates that travels with a product, and I have a very fine-grained overview of exactly the actual process that this product went through, you can show some very deep insights into your suppliers or your competitors. But here we find that sort of aggregating the certificates and having something which we call a release credential allows us to not disclose any information, but retain this verifiability of the credentials. One of the things that SICPA is known for, and where we come from, really our bread and butter, is something called product marking, which really sort of guarantees that what it says on the package is actually what's inside the package. So this is not just any other blockchain system. In order for this to work, one of the things that we found that you need to be able to guarantee is that there's really a strong binding between the physical component and what is the digital counterpart or the owner of the wallet. The second thing we found is that when you look at the digital side of the equation, you need to build this on global open standards. There's simply no other way that you can do this than a flexible, decentralized way that can be respectful for a wide range of different processes, different systems in supply chains, and different companies and regulations. So there's no way that there's going to be any central system or any prescriptive technology that is going to drive this. It needs to be fitting to whatever is the environment of the real world. And that brings us to the last point, where a lot of the things come down to making for very easy integration. So a lot of the customers that we speak to, one of their big fears is that they usually just finished their SAP integration after 6 years. And what they are really afraid of is that they are introducing a new system. And with microcertificates, actually the integration is super lightweight because we have unified interfaces, and the data basically travels in a decentralized manner with the batch and process. So you have really an enhancement of all the existing systems rather than a replacement. Looking at the technology of credential-based identity, and Fabián touched on it already. This is coming from the people identity stuff, but it's really moving towards, I would say, universal applicability, because it's a model for managing identities in which an individual or an entity, and this entity can be an organization, but it can also be a product or a batch, has sovereignty over the ability to control how information is disclosed and used. This does not mean that you own your own data, which is a common misconception. So it still relies on traditional issuers. So for people identity, this is typically the government. But for product information or batch information, this is where the producer has a lot to say about what type of information goes into the wallet of the product. And in practical terms, it's really sort of a standardized way to issue, manage, and verify any type of digital credential that is linked to a person, an organization, or a thing. It's built on open standards, so that allows you for the reuse of credentials across different domains. It gives identity holders the ability to prove things about their identity independently from the issuer. And this is important, especially in supply chains, because you don't want to be phoning home to the original issuer. So I can prove a thing about myself without having to ask the government saying, hey, there is some border patrol officer in Spain who is asking me for my passport. And we can do that in a privacy preserving manner. So we can do selective disclosure. We can offer anti-tampering guarantees. So this is the integrity that we normally get from blockchains. We can get that cryptographically through signatures. And this offers data portability. I can basically take my own data. It doesn't require any special hardware, and it's designed to work with existing systems. And this works best when there is an ecosystem of multiple independent issuers, and all of these issuers, they need to have a certain control of sort of what it is that they issue, what it is that they revoke, which can also happen. For instance, if you have a batch of baby milk powder and you find out something is wrong, you might want to revoke, even though it's somewhere in your supply chain. You can revoke a right to sell or an activity flag. And independently from wherever the product is, you can make it unsellable. When there's a variety of independent services and verifiers, so again, this comes back to sort of complex supply chains where in some cases you are a supplier, in other cases you are a client, and depending on the different contexts, there is a wide variety of different actors. So you need to be able to scale. But you also need to unify how you can verify and how you can build trust in different batches and products that you receive, rather than doing an incoming QA or an outgoing QA on every single piece of products that you have. What really helps, what we see in sort of implementation, is when there are governing bodies that can harmonize regulation, also indicating that this is not so much a technical problem, but it's also about how do we define what do we need to control. So data schemas, how do we define when we trust something, levels of assurance, all of that is important. And all of that can be governed by bodies. So we really see almost a renewed role for these governing bodies, which are usually much more active post-fact, sort of in auditing and sort of giving fines and things like that, to really being more proactive at the front of the process and helping industries sort of adopt these systems in a way that gives them certainty on how they can operate. And it's very useful when there's diversity in the holders of identity and their needs. So this means different environments, different use cases. There's no one factory floor that is the same. There are people involved, there are machines involved, and that diversity that I feel is brought by Industry 4.0 is actually very, very suitable for this type of technology. It's based on roughly 2 open standards. I say roughly, is like obviously within technology, there are many different things that matter, but these are the things that matter most. Decentralized identifiers and verifiable credentials. And as Fabián mentioned earlier, decentralized identifiers, they're slightly different from centralized identifiers. Mostly in the way that they do not require a centralized registration authority. And that seems quite trivial, but it enables quite a lot of things because you can have guarantees about the global uniqueness of a thing, which matters quite a lot in complex supply chains. They are persistent, So they don't change over time. So if you have a vendor that is going out of business, you don't suddenly lose information which is tied to centralized identifiers. They're highly available because they travel with the badge. They're under control of the holder, which in our case is the batch of products, and they can be claimed rather than are issued. Which again sort of saves you a ton of complexity when introducing these types of systems. Verifiable credentials, on the other hand, are about the information that is connected to the decentralized identifier. So if you have a decentralized identifier, so I can claim any number, how do you know that the information that is connected to that identifier is actually true? And this is where verifiable credentials play a role, because they allow for the independent verification of four things. Who issued something, to whom it was issued, and are you actually the owner, or is this a copy? That the credential was not revoked, and that the credential was not changed. So this is where the integrity really comes in, is this is independently verifiable and provable without the need for a central database. And this is really the magic that credentials offer, because this allows you to do some very interesting things. It allows you to reuse trust that was issued to you independently from the original issuer, which gives you data portability, it gives you interoperability across domains. But it also gives you privacy and confidentiality by design, because if I don't have to phone home to the original system, I don't have to have access to that system, and I don't have to sort of have heavy sort of VPN type things where I go into your file and maybe see a lot more than you want me to see. And on the other hand, for issuers and verifiers, it allows you to automate processes. If I have a product coming in or a batch of products coming in, which can prove that it was QA'd, outgoing QA, and it can prove their certificate of compliance or their certificate of conformity, I don't need to have an incoming QA. I can just trust it and let it pass. So those are things that we feel make it extremely useful in supply chains. So a little example that we did, because we wanted to validate these ideas and really go from a somewhat theoretical concept and say, okay, does this work? And where better to try this than in a highly regulated industry? Because if everybody knows, it's always best to experiment in pharma, because you can be sure that they will push back on everything that you say. So here the challenge was really to simplify what is called the trusted release process of a large pharmaceutical company. And what that comes down to is this pharmaceutical company has 80,000 suppliers. It's an extremely complex network. And their vision for microcertificates was, we don't want to have audits ever again. And why is that? That whenever there is a batch of medication to be released, it goes through the trusted release process. And the trusted release process is very interesting in the way that there is a qualified person who is legally liable for ensuring that for that batch, all the relevant certificates are present. And as you can see by this fishbone, there are a lot of these certificates. And they told us the story that their way of automating this process has been to give the binders, and you can see some of them here, to give them RFID tags so they would be more easily retrievable. And for any one batch, they would have a table 2 by 2 with up to a meter high files, and everything had to be checked by hand before the batch could be released. So obviously this takes a lot of time. It's very prone to errors. It's very hard to find what is missing. And we felt that microcertificates could actually be a nice problem, where you could say, well, can we let the batch prove itself that they comply with all the certificates, and that all of them are present, and that everything that needs to be there is there. So basically, the trusted release is just the click of a button. So we went out and we built a proof of concept, which I will show you now. So this is what you're seeing here is a simulation of different systems in pharma. So we have an ERP system, we have a production machine, typical sort of IoT thing, and we have a LIMS system, which is the QA system in pharma. And we're going to simulate a production pipeline where we're going to have some deviation results in the operator trainings. So what is going to happen is the system in the background is going to create in real time microcertificates for every step along the way. So this is something where we create the batch name, we create when it's created, what the brand is, what the type, and as the batch goes through the production line, certificates get added to the wallet of the batch. So what you will see in a minute is that these data is all sort of collected, and we're cheating a little bit, because what you see here is what's inside the wallet of the batch, and normally you would not see this. But every piece of data is signed, it's time stamped, and the value and key pair are we can be sure about the integrity because they're credentials. Now, what we're going to simulate now is if you're a qualified person, you want to verify this pipeline. So again, this is what a qualified person would see. It would see all the certificates, it could see the values of them, it could see all of them being present. And it could see where there's, for instance, a deviation. So as you remember, for the operator training, we had a minor deviation. So this could, for instance, be an operator not authenticating with the machine, which leads the machine to say, hey, there's an untrained operator here. So what would typically happen is that a qualified person could file an investigation report and say, now it's fine to release. And what happens here in this step is the part where we retain the confidentiality, because the release credential is the aggregate credential, which has a hash of the underlying certificates, and it has all the exception comments. But that is linked to the internal batch credential, which shows all the nested certificates. So if I were an auditor and I were to go back to this with the release credential, I could prove whether or not the underlying certificates that are shown to me by the producer are actually tampered with, or are they showing me the full record as it was on release. So going through that a little bit step by step, we take a step where we initialize the batch, and we have a list of batch requirements. So on the right-hand side here, you see these are the list of batch requirements of which we need to have certificates. And as we go through the production, we start filling in those certificates. So this also means that if certificates are missing, the system would raise a flag and say, hey, you're missing a vital certificate. And what we do and what we tested sort of in the field was saying, hey, we have some machines that are qualified, so they are trusted. They can add their information from their system and we can trust it. But for instance, things from a standard operating procedure are often sort of, they're in Excel sheets or they're on pieces of paper. And even there, we were able to catch those things. They just take a little bit longer to go into the system. But actually, it turns out you can combine fully automated to fully manual processes and adding the different certificates that you need. Because even if the manual ones make a mistake, you can rely on the consistency of your process and your understanding of the standard operating procedure to find out whether that was sort of an honest mistake or whether something was wrong. Give you an example. If you have a batch of 400 insulin pens and the output of some machine is 350 insulin pens, usually you know something is wrong and either some sort of fraud happened or the machine broke down quite severely. And these are things that you can pick up from the microcertificates. So we continue and we collect microcertificates in the wallets. And then all the way until the end, you have an end-to-end consistency of the process. So what you would see here is typically what the qualified person would see. And all he or she needed to do is basically release the batch with one click of a button. So that leads us to sort of the final slide. We are quite excited about the combination of Industry 4.0 and credential-based identity because it allows us to build this system of microcertificates. So the microcertificates are different from the normal certificates, which are really bound to a producer, and they really give a reflection of any specific batch or any specific product that goes through a supply chain. You can really trace end-to-end what happened to it. It's very flexible and it has provable event caption. So that allows you to do a lot of automation. And the interesting thing is that it doesn't allow you to do automation inside your organization, but it's the first time that it allows you for automation outside across a supply chain. Because that we feel is super powerful, that if you have that type of information, that is a needed step in order to go to self-driving supply chains. Because no supply chain manager actually wants to manage its supply chain. Basically, the purpose of supply chain management is to get stuff from A to B for a certain price with a certain quality. And what if you could create a system where, based on trustable information that travels with the product, you can automate and say, I am willing to pay a little bit more, provided I have it earlier, given a certain quality. And you would just have to look at the microcertificate to see if it meets the quality. And then you can start to sort of automatically route different batches differently through your supply chain. And we feel that is what really sort of could happen when you start enabling trust in this way, and you can start really creating marketplace dynamics in complex supply chains. And with that, I would like to thank you for your attention and open the floor for questions. Please not in Spanish, otherwise I will kindly refer to Fabián.
Thank you very much, Bart. So now we're going to delve into the question round. We're going to try to do it without moderation. If we maintain a certain order, I think it would be all right. So I think there are many topics here, very interesting, which have been touched: security, the complexity, new technologies. If anyone had a question, please. Well, if no one has a question, I would like to ask. I think Bart touched this topic. I think Fabián touched it a bit more. My question to both of you is if you think really biometrics is secure enough to guarantee no personality or no identity forging. Because we know that biometrics is only a transformation of part of the information of a photograph or some other medium. So there's talk now about the importance of face recognition algorithms that can be replicated and used to access phones, for example, which are not yours, without even having seen your photograph, only based on biometrics. So I would like to know your opinion on that, please.
So I'll go first, Fabián, if you allow me.
Go ahead, please.
I think biometrics is a space of much nuance. I think security is wholly dependent on what is the larger context. What are we securing for? Your example of phones is an interesting one. Because the sensors are usually not too high quality, which doesn't really matter because it's a one-to-one matching. However, that leaves you with a vulnerability. So I think in that context, biometrics alone it's not as high quality. I think the misuse risk there is relatively low, however. It becomes different when you start looking at one-to-many matching, right? When you start to sort of have wide-scale scanning of faces to do detection of things. I would say aside from the ethical issues that arise from that, I think we're only at the beginning when it comes to interpreting things like biometrics and transforming that into something which makes sense, right? Because the reason why we use biometrics is to identify somebody, but we identify somebody because there is something of value or something of interest around this person. And I think we have a lot of ground to cover until we get to the point where we can really be sure about what is the meaning of things. I can recognize somebody. For me, it makes me feel very uneasy if that ties to systems which give me a risk score or give me a thing like that. On the other hand, to take a bit more positive note, we do see very interesting applications of biometry, especially when it comes to places where technology is not as widespread and where it brings inclusivity. So you can think about digital identity without a wallet, for instance. How do you give digital identity to people who live in rural areas in Asia or Africa? They don't have a smartphone, they don't have a tool, they don't have a piece of paper that they can lose. And there I feel biometry actually has a role to play, and there are the trade-offs between the risks of misuse and the value it adds, I think becomes a little bit different and a little bit more in favor of using it. But it's like nuclear energy. It needs to be handled with extreme care, and it needs to be thought out, which is very hard in complex systems because there's always unintended consequences that you did not see coming. So I think doing it is good. Technology can improve. The key part is the regulatory framework, because ultimately this is about people, and the technology does one thing, but when we talk about meaning, when we talk about recourse, you need to have a very, very strong regulatory framework.
Yep, I couldn't agree more on what Bart says, as always, as an expert on that field. From the point of view of GDPR, we are having serious issues on regards, as Bart said, on the information that we store that is not allowed according, for instance, the European regulations. So it's for that reason that the first we need to avoid the bad use of images, as we have been mentioning, for instance, the impersonation, that is whenever someone tries to be or to act as another person. And we use a kind of liveness techniques to see whether if it's alive, the people that is in front of the camera of the smartphone or not. And what we store, as we were mentioning, is just a hash of the picture of the face of the person, but there is a lot of different biometrics that are in use. We are hardly investigating on that field, and I think that this is a big opportunity to collaborate with the Polytechnic University. We used to work together with universities like the Polytechnic University, for instance. Now we are working in close cooperation with the Polytechnic University of Madrid for things related to the Agro 4.0. That means we have been talking about the pharmaceutical, about the identification of people, but we are working also in projects very interesting on the Green Deal, that is the European new way of thinking about the agriculture, forestry, and all things related to the development in a sustainable way. So I encourage you to help us from the university, Ignacio, that you are fully involved on all these topics, to help us on the new future that is in front of us on regards to many topics related to the new way of working with the new techniques around blockchain and the future that is nowadays popping up.
Of course, I would be delighted. In fact, my background has a bit of artificial intelligence in it and artificial vision, so I have some background on all these topics. Has anybody has a question? I could go on talking about this topic for all night, so it's better that someone produced a question quickly. Okay, just let me go on with it. I would also like a sort of unifying overview about this, because I see many topics coming into microcertificates and all related with Industry 4.0, but I think that there are some issues here. For example, you both have been talking about ways of managing complexity, very large collection of data, and the possibilities that this brings or open to us. Of course, that's the link with industry is evident, but it could be extensive to great sets of people. For example, population of countries, cities, or continents. I don't know if you see any relation between this and some measures that we are seeing of supervision of streets with cameras and automatic detection of people and so on. I would like your opinion about this and how it could alter the privacy and all those issues that we are actually currently arising now.
I think that, Bart, if I may, I think that one of the advantages that we are having thanks to blockchain is that when we are asked to provide information about us, we can just provide the information that is needed. For instance, if I'm going to have a drink with alcohol, only thing that the other person needs to know is if I am older than 18 or not. So I can show a credential just justifying that I am having 45 years or I am older than 18. So in this respect, I think that thanks to blockchain, we can increase our privacy and intimacy. Another thing is what you mentioned related to the cameras on the street and recording things, and that's what happened in some countries that we may imagine. But now under the umbrella of the GDPR regulation in Europe, I think that there is a strict rules to follow. But Bart, for sure, that will emphasize a bit more on this topic.
Sure. No, I love that you ask it. I once gave a presentation on technology and privacy. the question on whether are they not mutually exclusive. What I think is that technology has always been this force of change ever since sort of the printing press, which is dear to SICPA's heart. That changed the whole dynamics. Basically, the Pope promising to excommunicate anyone who printed manuscripts without the church approval, and that happening soon after. To the development of privacy. And privacy actually comes from, at least in the US, the Harvard Law Review, I think it was somewhere in 1890, when Warren and Brandeis basically discussed the right to be let alone due to photographs being taken and being posted in newspapers. So this is I would say a super interesting field that we can do much more, but we can lose trust in the system also much more quickly. There's an interesting statistics that there is about 250,000 data records lost or stolen every hour since 2014. So if you think about that, that can have very severe consequences, especially if you look at what Fabián mentioned. Sort of, you look at countries like China. Last year, or actually 2 years ago, it's 2021. I have to remind myself. You had close to 14 million people deemed untrustworthy due to their social credit system, for me that is worrisome. And I feel that the thing that we are seeing now is new technology enabling new types of things. So if you have sort of a 2x2 matrix, you can have two axes. The one is I trust somebody, the other one is I verify something. And then on the vertical axis, you have sort of your level of assurance from low to high. What you saw is that yesterday I trusted things of low assurance. Basically, I know because you told me something, or I know what is in the record for you, and then I basically verified with high assurance. Today, we see a lot of low assurance verification things, your social media behavior, cameras on the streets. Basically, it's reliant on everything I record of you. But I have no influence on that. And I think the interesting part about the new technology that we see today is that it's the first time that I can prove things about myself to you. So I have the more control, which I think is extremely important when we don't want to lose trust in these systems. Because I think if we lose the trust in these technology systems, you can end up in a very, very bad place.
Of course you do. I think there are many issues to work out yet. We're only starting this revolution, I think. Once again, I ask for questions because I've got some more. Anybody wants to intervene?
Ignacio, I don't know if you can hear me.
Yep. Go on, Cesar.
Yeah, I don't know if Bart or Fabián, whenever we talk about distributing authorization and all these kind of things, and especially talking about microcertificates, then the question goes to standards. Okay, so who is ensuring that once you distribute all the architecture, that architecture remains the same? Okay, and I don't know, 15 years from now, you can still validate that. I mean, you lose control. So at one point of the system, if all the standards are not completely standard, then you end up in a little bit of an spaghetti certification architecture.
Yeah, absolutely. So this is one of the reasons why we look at the slow-moving global standards, which are, I would say, painful to work with from time to time, especially in sort of establishing them. But you need to have that slow-moving technology backbone. So the standards that we spoke of, they're developed by the World Wide Web Consortium. And that's the consortium that gave us HTTP and mail. So we're pretty confident that that's sort of the technology basis that we need. But that doesn't mean necessarily that things will magically work together, because there's the theory of standards, and then there's the practical way of making it work. So we also spent significant time in actually guaranteeing that we have interoperability. So there are initiatives that we are part of that prove interoperability between different parties on certain elements of the technology, which I think is going to be very good in the marketplace. If you are a provider that can say, hey, I am adhering to these standards and I can prove to you that I am interoperable with other players. The caveat here is, I think, mostly on the industry itself, where I see a big role for governing bodies, because you can have technical interoperability, but that doesn't necessarily mean you have semantic interoperability. So does a term in quality assurance mean what it means for the other provider who may be operating in a different domain? Because maybe this pharmaceutical company has a supplier who also works in food, and the standards there are slightly different. We feel that it's likely that either the big auditors, so the SGS and then the DNVs of the world, or semantic standards body like GS1 are going to play a big role. And we see a movement towards that direction. GS1 is very active in the space of decentralized identifiers, especially for standardizing the semantics across an industry. But that's absolutely needed, and we're trying to go for the slow-moving stuff, because we know it will have longevity that is needed, because otherwise you'll end up in, I would say, SAP world, which is like takes you a long time. You can do a lot with it, but nobody's really happy with it, and it comes with its own set of problems, and that's what we're actually trying to prevent. But you need to have that longevity in order for that to work.
Querido Decano, Dean, thank you very much for your question. That is the spaghetti things that are always surrounding our work on IT. And in this case, for instance, this is an excellent question, because one of the challenges that we are having in the SIF Lab project, that is the European Self-Sovereign Identity project that we are running for the European Union, is focused on the interoperability. For instance, if you remember the picture that I present with the issuer, the person, and the wallet, and the verifier, what we are confronted with the other cohorts member of this call of the European Union was to prove the interoperability in between different verifiers and different issuers and different wallets. So the trick is on achieving this interoperability, as Bart was mentioning. That is, for instance, a clear topic and a challenge that was on the table on the project that we want in the European Union. So good question. We are working on that, and legislation and standard are coming afterwards normally. But as Bart mentioned, that's something that takes time, but is produced in a safe manner at this very moment. And W3C is the base in which we are following the standard that are at this very moment issued by them.
Okay, thank you very much. Do we have any more questions? Okay, I would like to pose a final question to our presenters. We've been talking here about many issues, many of them cutting edge issues, and I think there are many challenges in front of us. I would like to know your opinion about the main difficulties or the main challenges that have to be overcome in order for to achieve a widespread deployment of microcertificates and the things we've been discussing on industry. I mean, it's clear that we're not yet, we do not yet know where the place to which this technology and this technology entails with it in itself a philosophy, a new way of working, and new things that will have to be done in a different way. For example, audits, as you have said. There are many more things, and there are certain barriers for the widespread development today. So I would like to know your opinion about the main ones.
So one of the big ones I see is the business model, and the interesting thing that we see happening, also being an incumbent somewhat, is that decentralization and microcertificates are also very much about unbundling. Unbundling of your identity card into credentials that you can reuse, or unbundling of pieces of information that sit inside an ERP system of a producer that is a competitive advantage that is being unbundled and given to the product. And everywhere where you see that happening, that unbundling in digital, you see a value shift from the supply side to the demand side. So if you think about Facebook unbundling newspapers and making a New York Times article just as valuable as a picture of your cat, the value shifts all the way to the aggregators, and we feel that that's very scary for an incumbent, because what do we do typically with our security features is we mark something to ensure the integrity of the issuer, the original issuer. And where we're going is the verification side of these credentials is going to be much more valuable. And I think the one major issue is, how can you create a business model which does justice to the people that need to adopt this and drive this and sort of say, yes, we want to embrace this technology, and others in the ecosystem, because that ecosystem is going to need to have a multifaceted business model is very clear. The pharmaceutical company that we worked with, they dubbed this sort of the $1 billion opportunity just for them. However, that $1 billion is being spent on some other providers who have a vested interest in never to see this happen. So the trick is going to be, how do you create fertile soil for value to be built on top? And in that case, I always look back sort of 20, 30 years ago, the early days of the web, where you say, how do you monetize HTTP or sort of a protocol level thing? And I think that we could not envision that companies like Facebook, like Google, like Amazon would be building that value on top. And so for me, the big challenge is finding the business model that creates that fertile soil to sort of say, there is so much more value from sharing that information for everybody than to keep it to yourself and have your short-term competitive advantage. But that's going to be a long road, because not everybody has the same interest. So it's going to be a game of incentives.
Yeah, I totally agree. If I may say something, after 40 years working on IT, on my experience, what happened is that technology is growing exponentially, but the adoption of the technology is going step by step of a stir. What that means that is after one generation when the technology is really adopted. So we are growing so fast from the point of view of development of new technologies, but the adoption takes a bit more time. sometimes a generation.
Thank you. I seem to have to share that observation. Yet, well, thank you very much. Thank you very much to you both for your excellent presentations and for opening our minds on this topic, which is certainly a bit obscure yet, and is prone to many reflections yet. Thank you very much to both of you. There are upcoming presentations and webinars for which I cannot give you dates yet, but there's one coming on electromobility, in which we will explore the implications of electric vehicles and batteries and so on. And there's one coming on patents. I think two interesting topics of the utmost importance nowadays. So on this note, I would like to end today's webinar, thanking again Bart and Fabián. Thank you for your presentations, and thank you all for being here with us. So.
Thank you very much to the Asociación de Antiguos Alumnos de la Escuela de Ingenieros Industriales, and especially to you, Ignacio, they are chairman of the association. Thank you very much for inviting us to this round.
Thank you.
Thank you.
Goodbye, Bart. Thank you. A pleasure meeting you.
Thank you. Likewise. Have a good evening.
Have a good evening. Bye.